In this video, I'm going to go over some examples of adding and subtracting rational expressions. But before I do that, I'm going to show you some examples of computing the least common denominator of two rational expressions. Let's start with computing the least common denominator of 7 over 36 and 9 over 20. Well, we abbreviate least common denominator with LCD. So the LCD of 7 over 36 and 9 over 20, this is equal to the least common multiple, or the LCM, of the denominators 36 and 20. And to find the LCM of 36 and 20, I'm going to write 36 as the product of its prime factors, and I'm going to write 20 as the product of its prime factors. So, LCM 36, when you write it as the product of its prime factors, it's 2 squared times 3 squared. And 20, when you write it as the product of its prime factors, it is 2 squared times 5. That's equal to the LCM of 2 squared times 3 squared. We don't have a power of 5, so I'm going to introduce a 5 to the power 0. Notice 5 to the power 0 is 1. It does not really affect the product. And then the second number, 20, we can write it as 2 squared times 3 to the power 0, because we do not have a power of 3, times 5, which I'm going to write it as 5 to the power 1. Now I compare the powers of 2 in the first and second expressions. And when I'm finding the LCM, I'll always take the higher power, the higher exponent. So 2 squared and 2 squared, well, they're the same, so I'm going to take 2 squared. Next, I'm going to compare 3 squared and 3 to the power 0. I take 3 squared because that's the higher power. Next, I compare 5 to the power 0 and 5 to the power 1. The higher power is 5 to the power 1. The LCM is 2 squared times 3 squared times 5 to the power 1, which is equal to 180. Next, let's find the least common denominator of 3 over x squared minus 2x plus 1 and 6x plus 1 over x squared minus 3x plus 2. So we're looking at the LCD of 3 over x squared minus 2x plus 1 and 6x plus 1 over x squared minus 3x plus 2. This is the LCM of x squared minus 2x plus 1 and x squared minus 3x plus 2. Next we factor. LCM, x squared minus 2x plus 1 when factored gives x minus 1 squared, and x squared minus 3x plus 2 when factored gives x minus 1, x minus 2. That's equal to the LCM of x minus 1 squared. I'm going to introduce a power of x minus 2, so that's x minus 2 to the power 0. Notice that's equal to 1. And the second expression is x minus 1, x minus 2. So when comparing x minus 1 squared and x minus 1, which is x minus 1 to the power 1, we take x minus 1 squared. And when comparing x minus 2 to the power 0 and x minus 2 to the power 1, we take x minus 2 to the power 1. So the least common denominator of the two rational expressions is x minus 1 squared times x minus 1. Now that we've seen examples of computing the least common denominator of two rational expressions, we are ready to add and subtract rational expressions. Here's the rule. To find the sum or difference of the rational expressions p over q and r over s, we need two numbers, a, which is the LCM of q and s divided by q, and b, which is the LCM of q and s divided by s. Notice q and s are the denominators of our rational expressions. It will always be true that a and b are whole numbers, and it will always be true that q times a will equal s times b will equal the least common multiple of q and s. To see that, simply cross multiply here and cross multiply here. Once we have a, we have b, and the least common multiple of q and s, we can add or subtract p over q and r over s by following this rule. Take p, which is the numerator of the first expression, multiply it by a, then add or subtract, depending on whether your expression is adding or subtracting, r, which is the numerator of the second rational expression, times b, and divide everything by the LCM of q and s. We're going to apply this rule to add or subtract various rational expressions. On one occasion, there is a shortcut to this rule. In other words, you can get to the answer a little bit faster. You can only apply this shortcut when the rational expressions have the same denominator. So let's say you have p over q plus or minus r over q. In this case, we can get the answer quickly simply by adding or subtracting the numerators and dividing the result by our denominator. So you can only apply the shortcuts when the denominators are equal, and that'll get you to the answer rather quickly. Let's look at the following examples of adding or subtracting rational expressions. I'm going to work out these examples in detail by applying the rules we just learned. The first example is rather simple, simply because the denominators are equal. So 1 over 12 plus 5 over 12. Since the denominators are equal, I'm simply going to add the numerators, 1 plus 5, and divide by 12. This is 6 over 12, which simplifies to 1/2. Next, let's add the rational expressions 2 over 3y plus 1 over 4y. Here notice that the denominators 3y and 4y are different, so we need to compute the LCM of these denominators. So we start out by computing the least common multiple of 3y and 4y. Well, that's going to be 3 times 4 times y, which is 12y. Next, we compute a, which is the least common multiple of 3y and 4y. That's 12y, and divided by 3y to give 4. And b is the least common multiple of 3y and 4y. That's 12y divided by 4y, which is equal to 3. With that in mind, 2 over 3y plus 1 over 4y is going to equal 2. The number 2, where does that come from? The number 2 is the numerator of the first rational expression. So that's 2 times a, which is 4, plus 1, which is the numerator of the second rational expression, times b, which is 3. And divide everything by the least common multiple of 3y and 4y, which we computed to be 12y. So the numerator is 8 plus 3, which is 11, divided by 12y. And that's the sum of the rational expressions 2 over 3y plus 1 over 4y. Next, let's look at 2x divided by x squared minus 1 minus 1 over x plus 1. We need the least common multiple of the denominators first. So least common multiple of x squared minus 1 and x plus 1 is the least common multiple of x squared minus 1 is x minus 1, x plus 1. X squared minus 1 is the difference of two squares of the form a squared minus b squared. So it factors as a minus b, a plus b. And x plus 1 is simply x plus 1. So the least common multiple of x minus 1, x plus 1, and x plus 1 is simply x minus 1 times x plus 1. Next, let's compute a, which is the least common multiple of the denominators. So x minus 1, x plus 1. And we divide by x squared minus 1. Well, that's simply 1. And b is the LCM, x minus 1, x plus 1, divided by x plus 1, and that's equal to x minus 1. So 2x, let me separate the screen before I do that. So 2x over x squared minus 1 minus 1 over x plus 1 is equal to 2x times a, which is 1, minus 1. This 1 is simply the numerator of the second rational expression, times b, all divided by the LCM of x squared minus 1 and x plus 1. We computed that to be x minus 1, x plus 1. So that's equal to 2x. We distribute. Minus 1 times x is minus x. And minus 1 times minus 1 is plus 1. Divided by x minus 1, x plus 1. Now the numerator is simply x plus 1, and the denominator is x minus 1, x plus 1. We can cancel out an x plus 1 to get a final answer of 1 over x minus 1. That is the difference of the two given rational expressions. Next, let's add 2x over x squared plus 5x plus 6, and x plus 1 over x squared plus 2x minus 3. First, we need the LCM of x squared plus 5x plus 6 and x squared plus 2x minus 3. This is the LCM of x squared plus 5x plus 6, one factor, gives x plus 2, x plus 3, and x squared plus 2x minus 3, one factored, gives x minus 1, x plus 3. So the LCM is x minus 1, x plus 2, x plus 3, all multiplied together. Now A is the LCM, which is x minus 1, x plus 2, x plus 3, all divided by x plus 2, x plus 3, which is the same as x squared plus 5x plus 6, and that's equal to x minus 1. B is the LCM, which is x minus 1, x plus 2, x plus 3, divided by x minus 1, x plus 3, which is x squared plus 2x minus 3. So we have x minus 1, x plus 3. After simplification, that's equal to x plus 2. So, let's recap. We have LCM of x squared plus 5x plus 6 and x squared plus 2x minus 3. We found that to be x minus 1, x plus 2, x plus 3. We also found that A is x minus 1 and B is x plus 2. We are ready to add the given rational expressions. 2x over x squared plus 5x plus 6 plus x plus 1 over x squared plus 2x minus 3 is equal to 2x times A plus x plus 1 times B, all divided by the least common multiple, which is x minus 1, x plus 2, x plus 3. Let's expand the denominator. 2x times x is 2x squared. 2x times minus 1 is minus 2x. X times x is x squared. X times 2 is 2x. 1 times x is x. And 1 times 2 is 2. All divided by x minus 1, x plus 2, x plus 3. When we combine like terms in the numerator, we see that 2x squared plus x squared, that's 3x squared, minus 2x plus 2x plus x is simply x, and we have a lone 2, so 3x squared plus x plus 2 over x minus 1, x plus 2, x plus 3. Now if we try to factor the numerator, namely 3x squared plus x plus 2, we see that we cannot do that. 3x squared plus x plus 2 cannot be factored over the real numbers, and therefore 3x squared plus x plus 2 over x minus 1, x plus 2, x plus 3 is as simplified as the sum of the given rational expressions get. So that is our final answer.